Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on trigonometry for mathematics grade 11, and this is part 3 of a 5-part video series. And in this part, we're going to focus on trigonometric equations. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 4 and 5 of this series and more videos we upload in the future. We have a lot to cover, so let's start. In summary, we're going to look at number 1, how to find the general solution of a trigonometric equation. Number 2, we're going to look at our solutions within a restriction and how to find those solutions. Number 3, we're going to look at co-functions, trigonometric equations, how to spot ones and how to solve them. Number 4, we're going to look at how to solve quadratic trigonometric equations. As you've noticed, we've got a variety of types of trigonometric equations you can find. Let's start with the first one. Now, before we do that, let's look at how to find the general solution of a trigonometric equation. In general, number 1, find the reference angle. That is step number 1. Number 2, you use the cast diagram to find where the trigonometric ratio is either positive or negative depending on the question you start off with. Number 3, we're going to use the reduction angle formulae to find the angle. Number 4, you check your answer. And lastly, number 5, you write the final solution. I'm going to demonstrate each and every one of these steps in a moment. Let's go. Now, to demonstrate how to find the general solution of a trigonometric equation, we're going to start off with the simplest we can find. And this question goes, determine the general solution for sine of theta equals to 0,3, correct to 1 decimal place. Please note, if they say correct to a particular number of decimal places, please stick to that. It's important for you to stick to that. We're going to stick to 1 decimal place. Step number 1, we said, step number 1, we must, step number 1, we find the reference angle. Okay, to find the reference angle, okay, how do we find the reference angle? Step number 1, so what you do is you take your angle theta, for this one will be equals to sine to the minus 1 or whatever trigonometric ratio of 0,3, the right hand side. Make sure that whether this is positive or negative on the right hand side, make sure that you enter a positive value when you're finding the reference angle. So now you take out a calculator, and in the calculator I'm going to show you exactly how you navigate that. Remember, they said correct to 1 decimal place, so we take a calculator and then we go second function or shift depending on what your calculator looks like. So that's shift in this case, and then you go sine. It will give you the sine to the minus 1 of, and then you go 0,3 inside the brackets, and it will give you the angle. The angle in this case is 17,4576 blah blah blah. However, they said we must leave our answer correct to 1 decimal place, so you round that off correct to 1 decimal place, and it will give us 17,5. Let's go 17,5 degrees. That's how you leave that in 1 decimal, correct within to 1 decimal place. Now that we found our reference angle, there is the reference angle, and you will see exactly how the reference angle works. Now we find where sine is positive in the cast diagram, because the original equation has got where the sine is positive. It is positive on the right hand side. So sine is positive in the first quadrant and the second quadrant according to. So it's positive here and it's positive there. Sine is positive in this, so we've used this cast diagram. Okay, sine is positive in quadrant 1 and 2. Sine is positive in quadrant 1 and quadrant 2. Now what do? We know that the angles are written in, or In quadrant 2, it's 180 degrees minus theta. Remember those reduction angle formulae? It's very important for you to remember that. We use all that information from video 1 and 2, all that training, we use it in this video. It's culminated into this video. So we look for where sine is positive in. Okay, sine is positive in quadrant 1 and quadrant 2. So in quadrant 1, this is how we express angles. It's just that theta. So theta will be equals to the reference angle plus K times 360 degrees. Why 360 degrees? Because that is the revolution, or that is the period. Yes, that is the period of our sine graph. So that's what we, because we're looking at the general equation. So whatever number of revolutions you go are catered for in the K times, where K is an integer. That's what K is. It's an integer. It could be positive, it could be negative, it could be 0, but it must be an integer. Now, in quadrant 1, therefore, our theta will be equals to, we go back to the reference angle we found, that will be 17,5 degrees plus K times 360 degrees. And we're done with for quadrant 1. Now let's do the same for quadrant 2, because it's also positive in quadrant 2. So in quadrant 2, our angles are expressed as 180 degrees minus theta. So that will be 180 degrees minus the reference angle times K plus K times 360 degrees, where K is an element of integers. I'm just lazy to write that, but it's very important to keep. So what's our reference angle? We'll go back to our reference angle again. The reference angle, that was 17,5 degrees. So that is minus 17,5 degrees plus K times 360 degrees, where K is an element of integers. Therefore, theta equals to, take out a calculator and we'll go 180 minus 17,5. 180 minus 17,5 degrees. And that gives us 162,5. So that will be 162,5 degrees. 162,5 degrees plus K times 360 degrees. Now let's check. When we're done with this, step number 3, we check. Actually, I think that is step number 4. However, okay. So step number 3. Okay, step number 3, we use the cast diagram. Okay, step number 4, that is checking. Step number 4 is check. Step number 3, we've already used that. Okay, step 3, use cast diagram. Alright. Okay, let's not waste time. Let's check. How do we check? We take the theta we found, the answer we found, the solution we found, and we substitute it back into the original equation. So where there is theta in the original equation, where there is theta, we must substitute the theta from quadrant 1 and the theta from quadrant 2 using our case. Alright, so let's check for quadrant 1. We're checking for quadrant 1 and we're going to use a positive K equals to 2. To accommodate all that, we're going to use K is equals to 2. So here is how we check. Left hand side equals to sine of where there is theta, we substitute 17,5 plus 2 times 360, because our k is positive 2. 17,5 degrees plus 2 times 360 degrees. And that should give us an answer that is equals to the right hand side. Let's check for that. Okay, so that is sine of, let's reduce this so that we can, sine of 17,5. So that is sine of 17,5 degrees plus 2 times 360 degrees. And that gives us an answer of 0,3007. You can see for yourself. That is 0,3007. 007 and so on and so forth, which is approximately equals to 0,3 when we round it off correct to one decimal there, which is equals to the right hand side. So this one checks out. Let's check the answer from quadrant 2. So wherever there is theta, we substitute 162,5 times, okay, in quadrant 2, check quadrant 2, and we're going to check with a k of a negative. Let's make that negative 3. K equals to negative 3. So therefore the left hand side equals to sine of, where there is theta, using quadrant 2, we substitute 162,5. So that will be 162,5 degrees minus 3 times 360 degrees. Okay, take out the calculator. Let's punch that. Okay, so that is sine of 162.5 plus negative, so it's minus 3 times 360, and that gives us 0,30075 blah blah blah, 0,300 blah blah blah, 0,300 blah blah blah, which is approximately 0,3, which is equals to the right hand side, and this one also checks out. Now the final step, which is step number 5, we write the final solution. Step number 5, we write the final solution. The solution is theta equals to 17,5 degrees plus k times 360 degrees, or theta is equal to 162,5 degrees plus k times 360 degrees, where k is an element of integers. This is very important. You get a mark for exactly writing where k equals to, where k is an element of integers. It's very important. Next, let's look at solutions within restrictions. What happens when, in addition to a general solution, they say to you, find a solution restricted to a certain restriction? For example, in this case, we're supposed to determine the general solution of x if cos of x, sine of x, square root of 3 sine of x are the first 3 terms of a linear number pattern. Then find the solution for your x between negative 360 degrees and 360 degrees. So what you do is you find the general solution first. And how do we find the general solution? We apply the information given to us in the question. We're dealing with a linear pattern, meaning that this is term 1, term 2, term 3. The definition of a linear pattern is such that T2 minus T1, the constant difference, is the same. T2 minus T1 equals to T3 minus T2. That is the definition of a linear pattern. This one is a linear pattern. So now, therefore, what we do is we take term number 2, that's sine x minus cos x. Sine x minus cos x equals to, and then the other one, term 3 is root 3 sine x, square root of 3 sine x minus sine x. So what you do is, okay, here is a shortcut. So now you end up with a situation where you've got two trigonometric ratios, one cos and the other one sine. It becomes a very difficult equation to solve this way. So what we do is we then change this into a single trigonometric ratio. How do we do that? Take all the sides to the left hand side and take the cos to the right hand side. So that's what we do. Take all the signs to the left hand side, minus square root of 3 sine of x plus sine of x, and then take the cos to the right hand side. In other words, let's separate these trigonometric ratios so that we can figure out a way to make them one. So this is 2 sine x minus 3, so that's 2 sine x minus root 3 sine x. This is equals to cos of x. Let's simplify this. Use whatever knowledge you have of simplifying trigonometric ratios to simplify this. Now here we go. Now here we are. So what you do here is you divide both sides by cos of x. Why? Because we want to achieve a situation where you've got only one trigonometric ratio, and in this case that trigonometric ratio will definitely be 10, because now we use the quotient now we use the quotient formula. It's called the quotient. Now we use the quotient ratio, the quotient identity, that's what I meant to say. Now we use the quotient identity to reduce this, so that becomes 10 of x equals to cos of x over cos of x. That leaves us with 1. They cancel out. So now we divide both sides by the 2 root 3, and that leaves us with a single trigonometric ratio, which was the goal. And this is that single trigonometric. Now that we have a single trigonometric ratio, we can go ahead and find the reference angle. So now the reference angle is theta equals to 10 to the minus 1 of all of that 2 minus root 3, and that will give us a reference angle of, take out a calculator. So we go shift 10, common fraction button, 1 over 2 minus root 3. Okay, let's just make sure that we, and that gives us 75 degrees. There is the 75 degrees. So that is 75 degrees. That is our reference angle. Now we look for where 10 is positive. The tangent of any angle is positive in the first quadrant and the third quadrant. 10 is positive in quadrant 1 and 3. Quad 1 and 3. Quad 1 and 3. Okay, so now we find what happens in quadrant 1. In quadrant 1, angles are written and defined as just theta. So that will be the reference angle plus k times 180 degrees. Reason being that the period for 10 is 180 degrees. That's why. Now we substitute the reference angle, therefore x equals to 75 degrees plus k times 180 degrees, where k is an element of integers, like it should always, where k is an element of integers. Now let's look for what the angle is in quadrant 3. In quadrant 3, angles are expressed as 180 plus theta in reduction angle formulae. So that will be x, therefore the x will be equals to 180 degrees plus the reference angle plus k times 180 degrees, where k is an element of integers. I won't necessarily always write that. Therefore x equals to 180 plus the reference angle is 75 degrees in this case, plus k times 180 degrees, and that gives us 180 plus 75, 180 plus 75, that gives us 255. Therefore x equals to 255 degrees plus k times 180 degrees. Now we check. Okay, we're not going to always check fully. Okay, so in quadrant 1 we'll just use 3, k equals to 3. Okay, checking in quadrant 1 using k equals to 3. Okay, what does that give us? So that will be what? On the left hand side, okay, the left hand side will be, okay, that will be sine of 75 plus 3 times. Okay, so that will be sine of, on the left hand side, on the left hand side it will be the sine of 75 plus 3 times 180 degrees minus cos of the same, minus cos of 75 plus 3 times 180. Let's fix that. Plus 3 times 180. 3 times 180. Okay, let's calculate that and see what it gives us. Okay, we should also calculate the right hand side. Right hand side, same way. All right, okay, so that will be sine of 75 plus 3 times 180. Sine of 75 plus 3 times 180 minus cos of 75 plus 3 times 180, and that gives us an answer of negative 0,071. Okay, let's see if we can use the S2D button. Okay, that gives us negative square root of 2 over 2. All right, negative square root of 2 over 2. So that is negative square root of 2 over 2. Let's see if this one gives us the same thing on the right hand side. Let's check the right hand side. That is the square root of sine x minus sine x. Okay, so that should be square root of 3 sine of 75. No, okay, we're going to use quadrant, quadrant 1. Okay, 75 plus 3 times 180 minus the sine of x, which is sine of 75 plus 3 times 180 degrees. Okay, let's see if it gives us that. So that is square root of 3 sine of 75 plus 3 times 180 minus the sine of 75 plus 3 times 180, and that should give us square root of negative square root of 2 over 2. Negative square root of 2 over 2. So the left hand side equals to the right hand side. So they both give us negative square root of 2 over 2. Right. So now we write the final answer. And the final answer should be easy. The final answer is simply that x equals to 75 plus. Okay, so we've checked. I just wanted to show you how to check. You don't always have to write it down, but you can check using your calculator directly. Alright, so we've checked and we've satisfied ourselves that you can also check for quadrant number 3 with k equals to negative 2 and satisfy your own curiosity that it is correct. I've shown you how to check, so that should be easy. So that will be, therefore, the solution is the general solution. Therefore, the general solution is x equals to 75 degrees plus k times 180 degrees, or x equals to 255 degrees plus k times 180 degrees, where k is an element of integers. Where k is an element of integers. Now we apply the restrictions to figure out where exactly the restrictions will be, what the limitations are. Let's apply the restrictions now. Alright, let's apply the restrictions. Okay, we know. Okay, let's just write that x equals to 75 degrees plus k times 180 degrees, and then we've got x equals to 255 degrees plus k times 180 degrees. I just wanted to write that. So what you do to find the solution within the restrictions is you apply your k. Start with k equals to 0, which is right in the middle. When k equals to 0 in quadrant 1, therefore our x will be 75 degrees plus 0 times 180, which is 75. And then, or x will be, the next one will be 255 plus 0 times 180, which is 255. Remember, the restriction must be between negative 360 and 360. So now we go to k equals to 1. We want to see for which k all of these will be inside or outside the restrictions. So we go k 75 plus 1 times 180, and then or x equals to 255 plus 1 times 180. Okay, let me just double check the 255. Yes, that is correct. All right, that will be 180 plus 75, 75 plus 180, that gives us 255, which is exactly the same as the 255. And then we go 255 plus 180, that gives us 435. You can see already that is outside the restrictions, but let's continue. 435. Next, we go for k equals to -1. Using this system will make sure you don't miss any. So we basically are going to use the number line, and this is how we're going to use the number line. We go from 0, then 1, then -1, 2, then -2, 3, then -3, until we get to all the case where you don't lie within the restrictions anymore. In other words, it's bigger than or outside the restrictions. So for k equals to -1, the first one will be 75 degrees plus -1 times 180. So that will be 75 minus 180, or this one will be 255 minus 180. So 75 minus 180, 75 minus 180, that gives us -105 minus 105. And then same 255 minus 180, that gives us 75. All right, that is 75. Okay, we're still within basically the restrictions. Now let's go k equals to 2. We're moving out. X will be equals to 75 plus 2 times 180. And that gives us 75 plus 2 times 180. That gives us 435. 435. Now let's or x equals to 255 plus 2 times 180. Let's 255 plus 2 times 180. That gives us 615. 615. Okay, both of these are outside restrictions, so we're good. Let's try k equals to -2 and see what happens here. X will be 75 minus 2 times 180, and then 255 minus 2 times 180. And there's 75 minus 2 times 180 gives us -285. -285. And this one gives us 255 minus 2 times 180. That gives us -105. -105 degrees. We can look for k equals to 3, but you can see already going through k equals to 3 will be a waste of time, because already k equals to 2 is already outside of the restrictions. So let's try k equals to -3. K equals to -3 and see if for k equals to -3 we've got x equals to 75 minus 3 times 180, and that gives us 75 minus 3 times 180. That is -465 minus 465. And then for the other one, or x equals to 255 minus 3 times 180, which is equals to 255 minus, let me just fix it there, 255. That gives us negative 285. Negative 285. Only this one is outside the restriction. Let's try k equals to negative 4 to see if there are any other solutions that are within the restrictions here. So that's negative 4 times 180. All right, 75 minus 4 times 18. So that's 75 minus 4. That gives us negative 645 minus 645. And then this one, 255 minus 4 times 180. And that is equals to 255 minus 4 times 180. That gives us negative 467. Negative 465. Sorry, about negative 465. Notice that these ones, both of them are outside the restrictions, so we eliminate them. In this k equals to negative 3, it is negative 456 that is outside the restriction. It's less than negative 360. This one is within the restriction. Now let's go and eliminate all of those that are outside restrictions. Okay, the first, for 0, x equals to k equals to 0, all of them are within restrictions. For k equals to 1, this one, 435 is outside the restriction, and then everyone else except for, let's see, so for k equals to, k equals to 3, k equals to 2, all of them are outside of the restriction. There's no point in going for k equals to 3 because all of them will automatically be outside of the restriction. Now here is what the solutions are within the restriction. So what you do is you order them in ascending order. So you start from the smallest one. The smallest is negative 285. Some of them are repeated, so you don't repeat them, you just choose one. The solution is x equals to, the smallest one is negative 285, negative 285 degrees, or x equals to, the next one is negative 105. Yes, it's negative 105, negative 105 degrees, or the next one is 75 degrees, and then where is k equals to, yes, or x equals to 75 degrees. That is 75 plus 180 is 255. Yeah, or x equals to 255. Yes, or x equals to 255. Make sure you note those that are repeated. Okay, so it's 75, 255. Okay, we've got that. Negative 105. Okay, 75 has already been chosen, and then we've got negative 285. So it goes from negative 285, negative 105, then 75, and then 200. This is the solution. That is the final solution. And that's how you find a solution that is within a restriction. In other words, a specific type of solution within the restrictions. And now a look at cofunctions and trigonometric equations. Determine the general solution for sine of x minus 30 degrees equals to cos of 2x. Notice that the angles are not the same. They are not the same. The angles are not the same, number one. Number two, also notice that the trigonometric ratios are also not the same. So you have a situation where you will need to use your co-functions to either express cos in terms of sine or sine in terms of cos. We're going to start with the option one. Okay, option one is when we express cos as a co-function of sine. So what we do is, therefore, on the left hand side remains exactly the same. What changes is, instead of cos 2 of x, we'll have the sine of 90 degrees minus 2x. Co-functions, right? Remember, cos of theta equals to the sine of 90 degrees minus that theta. So that's what we do here. We treated 2x as theta. So now we've got the sine of one angle equals to the sine of the other angle. That means, therefore, the angles are equal. If the sine of one angle is equal to the sine of the other one, then the angles are equal. So that will be 90 degrees minus 2x plus, and then we put the periodicity, k times 360 degrees, where k is an element of integers. This is for when in quadrant one, where signs are positive, where sine is positive for both of them. Sine is positive in quadrant one and quadrant two, so this will be for quadrant one. Okay, sine is positive in quadrant one and two. In quadrant one, we just simply have this as it is with the reference angle. So what we do is we take everything, that will be equals to 90 degrees minus 2x plus k times 360 degrees, where k is an element of integers. So we take all the x's together. It's exactly the way it is. So that will be 90 degrees plus 30 degrees plus k times 360 degrees. In the first quadrant, it's just the reference angle. So we're not adding anything, we're not changing anything. So that becomes 3x equals to 120 degrees plus k times 360 degrees. Now we divide both sides by 3. Sorry, you must make sure that you divide. As soon as you divide one side by anything, you must divide the other side by the same thing, including the period. The period for sine is 360. That's why the periodicity gives us that. Therefore, x is equals to 120 divided by 3, that is 40 degrees, plus k times 360 divided by 3, that is 120 degrees. That is the first solution. All right, now, or in quadrant 2, sine is positive also. So this is the scenario we have in quadrant 2. Remember, in quadrant 2, your angle is 180 degrees minus theta. So the angle that we used as a reference angle, which is on the right hand side, because that's what we turned into a sine with that, will have 180 minus that. So in quadrant 2, we will have the scenario exactly the way it is on the left hand side. There it will be x minus 30 degrees on the left hand side. What changes is the right hand side, which is where our reference angle is located. That will be equals to 180 degrees minus that. So that was minus 90 minus 2x plus k times 360 degrees. Expand, add like terms. So that would be minus 30 degrees. 180 minus 90 plus 2x, so that's 90 degrees, plus 2x plus k times 360. Now we take the 2x to the left hand side. X minus 2x equals to 90 degrees plus 30 degrees plus k times 360 degrees. Negative x equals to 120 degrees plus k times 360 degrees. And there is, or you can say x equals to, divide both all of this by negative 120 degrees minus k times 360 degrees. Note that negative 120 degrees is the same as 360 minus 120 degrees, which gives us 240 degrees. Just keep that in mind. So yes, x can also be written as 240 degrees plus k times 360 degrees, with your k obviously being negative. That is option 1. You can even check, let's check. Let's check quadrant 1 with k equals to 2. The left hand side will be equals to sine of x minus 30 degrees. X is 40 minus 40 degrees plus 2 times 120 degrees minus 30 degrees, and that gives us, go 40 sine of 40 plus 2 times 120, all of that minus 30 degrees gives us negative 0,939 minus 0,939, negative 0,939, blah blah blah. And then let's check the right hand side. The right hand side for this particular question would be sine of 90 minus 2 times that. Okay, so it will be the sine of 90 degrees minus 2 times 40 degrees plus 2 times 120. Let's check that one. So that is sine of 90 degrees minus 2 times 40 plus 2 times 120 degrees, and it gives us exactly the same answer, negative 0,939. So it checks out. Negative 0,939 and blah blah blah. So this one checks out. Let's now go for option number 2. Option number 2 is when you now convert sine into cos. All right, let's look at option number 2. Option 2 of the same answer. Option 2 is when you express sine in terms of cos. In terms of cos. All right, let's do that. So on the left hand side, we had sine of x minus 30 degrees equals to cos of 2x. On the left hand side, so what we do is we express sine in terms of cos, so that will be cos of the cofunction, that will be the cos of 90 degrees minus the angle x minus 30 degrees cos of 2x. Therefore, we've got the cos of one angle equals to the cos of another angle. That means therefore the angles will be equal, so meaning that we'll end up with 90 degrees minus x minus 30 equals to the angle on the right hand side, which is 2x, plus k times the period for cos, which is 360 degrees. Our cos is positive in quadrant 1 and 4. Don't forget that there is the cast diagram. That's what the cast diagram tells us. Quadrant 1 and 4. Keep that in mind. Now in quadrant 1, the scenario is exactly the way it is over here. The reference angle is catered for. In quadrant 1, 90 degrees minus x plus 30 equals to, on the right hand side we've got 2x plus k times 360 degrees giving us negative x equals to, okay, plus 120 equals to 2x plus k times 360 . That leaves us with negative x minus 2x equals to negative 120 plus k times 360 degrees. Therefore, negative 3x equals to negative 120 plus k times 360 degrees, which leaves us with, if we divide both sides by negative 3, that leaves us with 40 degrees. Plus, you can write it as minus, but you can write it as k times 120 degrees. It will be taken care of by the integer k equals to minus 1. So where k is an element of integers, so that is taken care of and catered for. Now in quadrant 4, you have 360 minus the reference angle. The reference angle is on the right hand side, so therefore we're going to have the left hand side 90 degrees minus x minus 30 degrees equals to 360 degrees minus 2x plus k times 360, where x is an element of integers. Now let's that will be minus x plus 120 equals to, just taking a shortcut there, 360 minus 2x plus k times 360, where k is an element of integers. So now take the x to the left hand side, minus x plus 2x equals to 360 minus 120 plus k times 360 degrees. And that leaves you with x equals to 240 degrees plus k times 360 degrees, where k is an element of integers. So both solutions basically give you 40 degrees and 240, with the other one giving you negative 120, which is exactly the same as 240, and we've demonstrated that. All right, therefore, now the final solution. The solution is x equals to 40 degrees plus k times 120 degrees, or x equals to 240 degrees plus k times 360 degrees. Now I want you to notice something, that 40 degrees can turn into 240 degrees if you find multiples of that, but that's what we have taken care of. So therefore, okay, where k is an element of integers, and that's how you find the solution. When you are dealing with a co-function situation, you can choose whichever option works for you. That's up to you. Now, number 8, the last one, let's look at the quadratic trigonometric equation. Here is an example. Determine the general solution of 6 sine squared theta plus cos of theta equals to 4. In this case, the sine square of theta can be, using the square identity, can be written as 1 minus sine squared, 1 minus cos squared theta, I mean to say 1 minus cos squared theta. For more on the square identity, please go, so you replace the, please go watch video number 2 in this series. You will see exactly how the square identity works. But let me just show you quickly. So we've got sine squared cos squared theta plus sine squared theta equals to 1. So to express sine squared theta, we can express that in terms of cos squared theta, and this is how. Just a quick recap there. So now you expand. That is equals to 4. Take everything to the right hand side. Therefore, 0 will be equals to 6 cos squared theta minus cos of theta. You can already see the plus 4 minus 6. And that gives us minus 2. So therefore, 0 equals to 6 cos squared theta minus cos of theta minus 2. That is equals to 0. Notice if you let this equal to k, if you let that equals to k, cos of theta equals to k, it will make your life so much easier. Let that equals to k. So that will be k squared and k. If you let k equals to cos of theta, therefore we have 6k squared minus k. So what you do is you replace where you see cos by k. Now this is a quadratic equation that's so much easier to factorize. Okay, let's factorize this quadratic equation. We've got 6. The factors of 6 are 6 and 1, 3 and 2. and then the factors of 2 are just simply 2 and 1. Now we need to find a combination that gives us 1 in the middle with a 2 on the outside. So the one that will give us 1 in the middle could be either be 3 times 2 or 2 times 1. Let's see which one. We must find the one that gives us 2 ultimately. So that's 2, 3 and 2. So let's go 3k and 2k. 3 times 1 will be 3, and then so that will be 3 minus 4. Let's see, 6k. So that is 6k squared catered for 3k, 4k. So that will be plus 3k minus 4k. That will give us -1, and then the sign on the last term also match out. Okay, if you're not sure, please quickly just multiply things out. So that will be 6k squared plus 3k minus 4k minus 2. This gives us -1. Perfect. So now we go, therefore 3k minus 2 equals to 0. Never skip this step. A lot of people skip this step and they get into trouble. 2k plus 1, that's when you make silly mistakes. Now let's sort that out. So that is, so we have 2k, 3k minus 2, therefore 3k equals to 2, or 2k equals to -1. There we go. Now therefore k equals to 2 over 3, or k equals to -1 over 2. But we're dealing with cos, so what we do is we replace cos back where there is k. Cos of theta equals to 2 over 3, or cos of theta equals to -1/2. Now we've got two scenarios, one where cos is positive and the other one where cos is negative. We're going to look at each one of these scenarios and find solutions for each one, which is exactly what we should do. Let's go back. I was just preparing the page for that. Now let's look at the first scenario. So remember, quadratic equations give you two options. For cos of theta equals to 2 over 3, let's work on this one. Cos is positive in quadrant. Where is cos positive? Here is the cos diagram. Cos is positive in quadrant 1 and 4. So cos is positive in quadrant 1 and 4. Let's draw a small line. Okay. Cos is positive in quad 1 and 4. In quad 1, in quadrant 1, this is the scenario. Our theta will be the reference angle. Okay, first of all, let's find the reference angle. We've got two options, two scenarios. Now let's find the reference angle. Okay, reference angle for this one is theta will be equals to cos of, and that will be equals to, the reference angle is shift cos, common fraction button, that's 2 over 3. That gives us 48,189. Let's leave it correct to two decimals. That is 48,2. 48,2 degrees. That's the reference angle for this one. Now the reference angle for the other one is, the reference angle for this one is theta equals to cos to the minus 1 of positive 1 over 2. Remember, you must make sure that you use the positive version. So let's find for 1 over 2. 1 over 2. And that gives us 60 degrees. So we've got two reference angles. This one is for when cos is positive and this one is for when cos is negative. So cos is positive on this one. Cos is positive in quadrant 1 and 4. There. So in quadrant 1, this is what we have as a situation. Our angle will simply be the reference angle plus k times 360 degrees, which leaves us with theta equals to 48.2 degrees plus k times 360 degrees. That's for when cos is positive and for quadrant 1. Let's look for the same scenario in quadrant 4. In quadrant 4. In quadrant 4. Our angle is 360 degrees minus theta. That's how we express the angle. 360 minus theta. So that will be 360 degrees minus the reference angle plus k times 360 degrees, which is the period for cos, plus k times 360. Therefore, theta will be equals to 360 minus 48.2 plus k times 360, where k is an element of integers. Therefore, theta equals to 360 minus 48.2. 360 minus 48.2, and that gives us 311.8 degrees. Plus k times 360 degrees, where k is an element of integers. Next, let's find for cos of theta equals to negative a half. The next solution is for cos of theta equals to negative half. The reference angle is theta equals to cos to the minus 1 of positive 1 over 2, and that gives us 60 degrees. Like we already calculated that. Now cos is negative in quadrant, coming to the cos diagram, it's negative in quadrant 2 and 3. Quadrant 2 and 3. Right, in quadrant 2, our angle is expressed as 180 minus theta. So that will be 180 degrees minus the reference angle plus k times 360 degrees, where k is an element of integers. So that's 180 minus 60 degrees plus k times 360, and that leaves us with an angle of 120 degrees plus k times 360 degrees, where k is an element of integers. Where k is an element of integers. Next, in quadrant 3, where cos A is negative. Okay, in quadrant 3, the angle is expressed as 180 degrees plus theta, so that will be 180 degrees plus the reference angle plus k times 360 degrees, where k is an element of integers. Therefore, theta will be equals to 180 plus 60 degrees plus k times 360 degrees, which is theta equals to 180 plus 360. 180 plus 60, not 180 plus 360, 180 plus 60, that is 240 degrees. That is 240 degrees plus k times 360 degrees. Now notice something, but 240 is simply equals to 2 times, yes, 240 is equals to simply 2 times 2 times 120 degrees, so we can divide both of them by 2. Therefore, but you can also leave it like that. Let's check. You can check any of these ones. Okay, let's check for 60 degrees. Okay, 1. All right, for k in quadrant 1, and k equals to 2. The left hand side will be equals to cos of 120 plus 2 times 360. And that is equals to cos of 120 plus 2 times 360. That gives us negative 1 over 2. Which is equals to right hand side, which checks out. We can also go back and check the other one, just one of them. Let's go back and check. Let's check quadrant 4 solution 311,8 plus, and let's use k equals to negative 3. So that will be k equals to negative 3. So that will be cos of 311.8 minus 3 times 360, and that will give us 0.6666. Let's use the S to D button. Alright, so it's 0.6665. Let's go 0.6665, 0.6665. No. Okay, let's find square root of 2 over 3. Okay, 2 over 3. 2 over 3. And that is exactly the same answer. So that also checks out. So meaning that our final solution will be all of this. Therefore, the solution is theta equals to, start with the first one. Okay, theta will be equals to 48,2 plus k times 360, and then 311,8. 48,2 theta equals to 48,2 plus k times 360 degrees, or theta equals to 311,8 degrees plus k times 360 degrees, or theta equals to, from this second pair, theta will be equals to 120 degrees plus k times 360 degrees, or theta equals to 240 degrees plus k times 360 degrees, where k is an element of integers. Always write this because you get marks for this.